Hi, sixth grade. I hope you're doing well. Can you believe it? Today is the day. Today's the last day of our video math class. We have one more live class together on Thursday, which will be our last day. Um, I can't believe it's already here. All right, well, let's get started with the chapter review and let's do number one together. Pause the video and let's see what you get. Okay? All right, see you soon. Okay, so looking at this table, which show the number of bedrooms in units of a new apartment building, um, it ranged from one bedroom to five bedrooms. Wow, the number, and so they want us to tabulate the data here. So we have the column, the number of bedrooms, and then a tally column, and then a frequency column. And so um, for one bedroom, how many are there? What I would do is I would go across like this and then see if I see a one. And once I see a one, I would just tally it. Then I would go to did I say column? I meant row. And then I would go to the second row and then see if I see a one and there's no one. Then I would go to the third row and then tally it. Then fourth row, tally it. Fifth row, there's a one and then tally it. Okay. Um, and so if you do that, you would tally everything like this. Okay. But the thing is, now that I tallied everything, I'm going to double check that I tallied it right just by seeing if I have enough tallies, if the number of tallies I have here match the pieces of data I have here. So let's see how many pieces of data I have. Let's see, I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so I have six groups of five, which is 6 times 5, which is 30. So I have 30 pieces of data. So my tally mark should be 30. So let's see, I'm going to count the fives first, okay, because it's easy for me to see if I tallied it, how many fives I have. So here's 5, 10, 15. Then I see another group of five here, 3 and a 2, right? 20. Then I see another group of five here, 3 and a 2. 25. Oh, this is a group of four. 25 plus 4 is 29. Oh no, I don't have enough pieces of data. So that tells me, okay, I have to go back and double check my work. So what you can do is you can do it again by, rows, or you can try a new way by going by columns and tallying it up. And once I double checked again, I realized, oh, I don't have enough threes here. I only wrote 8 threes, but there were actually 9 threes once I double checked. Okay, and then so now I have 30 pieces of data here. So now I'm gonna just count my tally marks and write it as a number. And so here they are. Okay. All right. Let's do the next one. Okay. Pause the video and please do only numbers 3, 5, and 7. You're going to do the evens for homework. Okay. All right. See you soon. Hey, let's look at number 3. Now, this is the age of marathon runners. Wow, isn't that cool? There's someone between 0 and 9 years old who runs in a marathon. That's amazing. So, how many data values are there? So, look at the frequency of runners here. So, they put it on the y-axis and I see it's 2, 4, 6, 8, 10, 12. So halfway between each mark will be let's see, here it's 1. Halfway between 2 and 4 is 3. Halfway between 4 and 6 is 5. Halfway between 6 and 8 is 7. Halfway between 8 and 10 is 9. Halfway between 10 and 12 is 11. And so what I like to do is I like to just write the number at the top of the bar to so I can count later. Okay, so here are the numbers. So this is 1, 7, 11, 5, and 1. So then now I'm going to add these numbers up to find the total data values. So I have 1 plus 7 is 8. 8 plus 11 is 19. 19 plus 5 is 24. 24 plus 1 is 25. So there are 25 data values. Okay, now let's look at number 5. So this shows the lengths of trout that were caught in a lake during a fishing competition, and they tell us the total number of trout. There's 50 data pieces, okay, over here. And so it says group the data into suitable intervals and tabulate them. Explain your choice of interval. So before I figure out my intervals, I guess I want to see how many of each I have, okay? So I'm going to look at my, I'm going to try to find my lowest, and my highest, okay? So my lowest length and my highest length. So here it is. After I went through all the data pieces, I found that 8 was my lowest and 18 was my greatest length, okay? And so I see from 8 to 18, the range is not too big. It's only 10, isn't it? Okay. And I'll show you how to find the range a little bit later. And so what I did was first I wanted to list out the lengths. Okay, so I have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And I alternated between blue and red, just so then it's easier for me to visually see it once I tally it up. Okay, so then again, I'm gonna go across, and then once I encounter an 8, I'm gonna like tally it, and then if I encounter another 8, I'm gonna tally it, and so forth. Okay, and so okay, I found 2 8s, and then 1 9, and so forth. Okay, once I tallied it up, and then if I add up all the tally marks, I do count that there were 50, okay, total. So that checks out, okay. And then I'm gonna write the frequency that correlates with the tally marks, okay, like so. All right, but I'm not done yet, okay, because it doesn't. I guess I could just individually use these marks and draw it in a histogram like this, where my interval would just be 1 inch in between, right? And there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay? 11 intervals where each interval represents just that number itself, okay? But remember with a histogram, okay, we want to have it be an interval where it's between certain numbers, okay? And so 1 is not enough, right? Just having one number in one interval is not enough in a histogram, okay? And so so just to organize my data even more, just to see it better, I drew a line here between every 2 interval. And when I figured out the range, which is I take the greatest value, 18, minus the lowest value, 8, I get 10, okay? So my range is not that large either. And I guess it's because they're measuring the size of trout. Okay, the difference between the size of trout that are caught is not going to be that large. Okay, although I do think 10 inches is quite large. It's almost like a full ruler, isn't it? Like, so um, what I notice is, hey, it would be great if my intervals, okay, um, were just 2 inches here. Okay, so you have between 8 and 9 in one interval. You have between 10 and 11 inches. You have between 12 and 13 inches. You have between 14 and 15 inches. You have between 16 and 17 inches. And here, oh, there's no um, span here. It's only one data value. So I'm going to just add a 19, okay? Just so then I can see that, oh, there is a equal interval here. And then how many intervals do I have? I have 1, 2, 3, 4, 5, 6. Okay. So I believe that this is enough for me to draw my histogram with. Yeah. Okay. And I just grouped the frequencies here because once when I tabulate my data, this is going to be 8 to 9, and then the frequency is 3. Between 10 to 11 inches, the frequency is 8. Between 12 to 13 inches, the frequency is 9. Between 14 and 15 inches, the frequency is 9 again. I'm sorry, sorry about that. Between 12 and 13, it was 19. Between 14 and 15, it was 9. 16 and 17, it was 5. 18 and 19, there was only 1. Okay. And so there it is. Okay. So this is my data that I tabulated. Okay. All right. Yeah. So let's look at number 7 now. Okay. In here it says the data shows the distances a golfer hits in yards in a long drive championship. Use the data to answer questions 7 and 8. Okay. So we're only going to do 7 and you're going to do 8. Okay. So let's see here. I'm going to find my lowest and highest. So my lowest is 244, my highest is 278. And I see that my range, when I do the highest minus the lowest data value, is 34. So my range is it looks kind of big, right? Okay. So to figure out like, well, what are the suitable intervals? Okay. How many intervals should I make? I look at 34, okay? And 34 then represents the number of yards, all right? So it's 34 yards. And do you guys remember how many feet are in a yard? Well, I know that in 1 yard is 3 feet, okay? And so I guess I just thought, well, if 1 yard is 3 feet, okay, maybe a number that makes sense to work with is 5 yards, okay? 5 yards is how many feet? So to get 1 yard to 5 yard, I had to multiply by 5. So then I have to do the same thing here, right? I have to multiply that by 5. So this is 15 feet, okay? So I thought, okay, it might be good to see an interval where there's a span of 5 yards, okay? Because that shows 15 feet, okay? A ball being hit like every 15 feet, okay? And I also picked 5 because when I look at the number 34, I can round up to a number where I can um, where I can get where I can divide it by the number of intervals where each interval spans 5. Okay, so if I round 34 up to 35, okay, then I see that, oh, if I do 35 divided by 7, which is the number of intervals, then each interval can span 5. Okay, 5 pieces of data, okay, which is just like 5 yards. All right, so here is my data chart here. Okay, and so across I'm going to write yards, and then I'm going to also tally it up because that makes it easy for me to see how many I have. Okay, so first I'm going to start with my lowest, which is 244. All right, and then I'm going to add um, 5 pieces of data. Okay, so it's 244, 245, 246, 247, 248. So there's 5 pieces of data. Okay, all right. Now my next interval, I'm not going to start with 248 because I already accounted for that in this first part here. So I have to start with the next number, which is 249. And then I'm going to account for 5 pieces of data. Okay, so it's 249, 250, 251, 252, 253. Do you see that? Okay. Now you're going to see a pattern where you want 5 pieces of data, but all you do is you're going to add 4. Okay? You're going to add 4. So 244 plus 4 is 248. 249 plus 4 is 253. Okay? And so that's what you're going to do here. Okay? For the rest of the pieces of data until you get to the last part here. Okay? Now look, there's 7 intervals to 1, 2, 3, 4, 5, 6, 7. And each interval has 5 pieces of data. Okay, and let's see. So I have my lowest starting from 244, and then I also have my highest here, which is 278. Okay, so good. So I labeled my intervals correctly. Okay, so now let's tally it up. And once I tally it up, okay, I see that there's 4 pieces of data, and then I marked it in yellow. That account for between 244 to 248 yards. There's 6 pieces of data, and I highlighted that in green for you. There's 5 pieces of data that are between 254 and 258 yards, and I highlighted that in blue for you here. And then there's 4 pieces of data that are between 259 and 263, and I highlighted that in lavender for you. And there's 3 pieces of data that are between 264 and 268, and I highlighted that in orange for you. And then there's 6 pieces of data that are between 269 and 273, and I highlighted that in blue for you, like a darker blue for you. And then finally, I see the unhighlighted pieces of data that are left is 274 and 278, and that's between 274 and 278, so that's only 2. Okay. And again, when I count all the tallies up, I see that it matches the number of data that I have in here, because the number of data that I have 1, 2, 3, and then 3 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3 times 10 is 30. So I have 30 pieces of data, and when I add all these tally marks up, there's 30 tally marks, okay? And also I can tell that I accounted for all of them because I highlighted them in different colors. So I can make sure that I use them all up. So let's write the frequencies by counting up the tallies, and here they are. Okay, so this is for number 7. Now remember, in a histogram, the more, the higher the number of intervals we have, the better it is for us to see how the data is spread, okay, to see the distribution of the data. The less number of intervals we have, the more difficult it is for us to actually see the distribution of the data values. All right. Can you guys please do numbers 9, 11, and 13 on your own? And let's check in together in a bit. Okay, so let's look at number 9. We want to count the number of cars that were observed together in this chart. So all we need to do is add 22, 45, 64, 57, 27, and 25 together, and you get 240 cars. Let's look at number 11. Okay, so for number 10, you're going to have to draw the histogram, but let's do number 11. Describe the distribution of the data. Suggest why that histogram has the shape that it does. Okay, so you guys have to draw the histogram. So I'm going to just describe the distribution of data by looking at our information in the table. Okay, so I see that the highest number of cars are 64 and 57. Okay, those are quite high. Okay, and it's between 8 o'clock to 8:59. Compared to, let's look at the lowest values, 22 cars between 7 o'clock and 7:29, and also 25 cars between 9:30 and 9:59. Why do you think that is? Well, remember, the topic of this situation is the number of cars passing a traffic light during peak hours on a Friday morning. So think about what happens for most people on Friday morning. Okay, let's see. Kids, they have to go to school, right? Adults, they go to work. A lot of the kids' schools, they may start around, between 8 to 9 in the morning. In addition, a lot of adults' places of work, they start probably around 9. A lot of adults have a 9 to 5 job, right? Okay. And so they don't want to leave too early and get to school or work too early and wait around. Okay. And they might just have to commute, I don't know how long their commute is. Okay. And so it makes sense that at a traffic stop, okay, that they will see the most between 8 to 8:59. All right. And then it kind of tapers off later on between 9 to 9:29, 9:30 to 9:59, right? There's less. And also, really early in the morning, there are less folks who actually are driving, okay, 7 to 7:29, okay? Yeah, so that's probably why the histogram has the shape that it does. All right, now these are quiz scores of 94 students. Now they don't give us this value X, okay? But you know how many students there are, right? Okay, so because you know how many students there are, and you know the number of students that are given, including X, we can write an equation to solve for X. Okay, that's how you do number 12. So that's a hint for number 12. But number 13 says draw a histogram to represent the data and describe the distribution of the data. So I'm going to draw the histogram for you. So first, I know I need a Y and X axes. And then I'm going to label my axes, where my X axes are the scores, and then my Y axis is the frequency, and in this case it represents the number of students. And I see that my number of students span from 3 all the way to 17. At least that's what I know without figuring out the value of X, because you're going to figure it out. I'm not going to do it for you on my histogram. And so I made sure I represented all the number of students here on my interval, on my y-axis here, okay? And so there it is. And then my scores, I just wrote these intervals down here, okay? And now I'm going to, I see between 14 and 16, there's 17 students. So I'm gonna draw a bar up to 17. Between 17 and 19 students, well, I'm not gonna draw it because you have to figure out X on your homework, okay? So I just wrote a question mark. Between 20 and 22, there's 3 students. 23 and 25, there's 5. 26 and 28, there's 12 students. Between 29 to 31 points, there's 15 students. Between 32 and 34 points, there's 17 students. Between 35 and 37 points, there's 10 students. And between 38 and 40 points, there's 8 students there. Okay, so that's number 13. Okay, and let's see. So this, it says to describe the distribution of data. Okay, well, it seems like, so if these are the scores on the test. Okay, and the lowest is between 14 and 16, and the highest is between 38 and 40. It looks like the highest value is 40, and then the lowest value is 14. Okay, and so I'm guessing the quiz was out of 40 points. That's what I'm guessing, okay, or assuming from my chart, my table, and from my histogram here, okay. And so it looks like, there was a good number of students who received between 14 and 16 out of 40 points, all right. So that's below getting a score of 50% on a quiz, okay? So wow, there were 17 students who got below, at least 17 students who got below a 50% on a quiz, okay? And so that's a lot. And then it looks like, I know that a score of 30 out of 40, which is 3/4, when I simplify it. So if I have a score of 30 out of 40, this is same thing as saying 3/4. And 3/4 is one of the fractions that I memorized, which is 75%. Okay, a score of 75%. I see that, okay, so between 30 and 40, okay, there was like 15 students, and then also, a little around here, it's like another number, like a high number of students who scored kind of average, okay, on the quiz as well. And then, there were some students who, got a pretty high score, okay, between 35 and 40 on the quiz here. Okay, and so that's me describing the distribution of data on the quiz. All right. Okay, well, let's celebrate. Yeah. I really care about you guys a lot. Thank you for being amazing students. I've been extremely blessed to have you all, each and every one of you. And I am so proud of you, just for all of your hard work, for getting to know you better through our classes and outside of our classes, and just seeing who you are as people. I am just so blessed to know you. I've had a lot of fun with you during our classes. So thank you for being just such a blessing to me. All right, well, that's all for our online videos, and I will see you for our last live class on Thursday. Bye!